Alright, this video is about multiplying, adding, and subtracting with radicals. So remember, to multiply radicals, you've got to multiply the inside number with the inside number. And then multiply the outside numbers with outside numbers. So in this case, in this example right here, I've got 3 radical 2 times 4 radical 7. So I multiply inside with inside. So the inside number is 14. And outside with outside. So 3 times 4. The outside number is 12. Remember, you always need to check to see if you can simplify it. Just like a fraction. You wouldn't leave 3/6. You would make it 1/2. Same thing with radicals. Gotta simplify. So in this case, the square root of 14, I don't know the square root of 14, and I can't break it into something I do know. So this is as simple as it gets. A reminder about multiplying radicals. Radicals have to be the same in order to multiply them. So I have to multiply a square root with a square root, a cube root with a cube root. Can't multiply them if they're different. Okay, so let's look at this problem. Negative 3 radical 6 times 2 radical 3. Multiply inside with inside, so that becomes the square root of 18. Outside with outside, so negative 6. And then I gotta simplify. So 18 becomes the square root of 9 times the square root of 2. So it's negative 6 times 3 times the square root of 2. So negative 18 square root of 2. And I'm done. For this next one, I need to distribute, because I need to multiply radical 10 by both of these terms. So this becomes the square root of 30 plus 4 times the square root of 50. Remember, inside with inside, outside with outside. There's an understood 1 there. So then can I simplify the square root of 30? Nope. Can I simplify the square root of 50? Yep. So 30 plus 4 times the square root of 25 times the square root of 2, square root of 30 plus 20 times the square root of 2. Square root of 25 is 5, so 4 times 5 is 20. Can I add these together? No, I can't add them together, and why not? Good. The square root of 30 is different than the square root of 2. They're not like terms, so I can't add them together. So that's as simple as it gets. In this problem, I need to do a lot of distributing. Multiply the first times the first, so 2 times the 4 gives me 8. Radical 3 times radical 2, so that's the square root of 6. And then I have to do 2 radical 3 times negative 3. So that's negative 2 times the 3 is 6, square root of 3. Then I need to do the square root of 5 times 4 square root of 2. So it's a positive 4 square root of 10. And then the square root of 5 times the negative 3. So negative 3 square root of 5. Once I do all that multiplying, the parentheses are gone. So now I have 4 terms. Remember, terms are separated by plus or minus. So I've got 4 terms here. Can I simplify any of them? This one's the square root of 6. Can't simplify that. Square root of 3. Can't simplify that. Square root of 10. Nope. And the square root of 5. Can't simplify any of them. Are any of them like terms? Can I add any of them together? Nope. So this answer has 4 terms. And I just leave it just like that. That's an exact answer. Okay. So adding and subtracting, like I said, you got to have like terms. So this first example, the square root of 2 plus 3 square root of 2, those are like terms. So my final answer becomes 3 plus the 1, so that becomes 4 square roots of 2. Remember, the radical stays the same. It's just like if I were to add 1x plus 3x, you would get 4x's. Same thing. Okay. Are these like terms? The second one, the cube root of 2 plus 3 times the square root of 2. These are not like terms because the radicals are different. One's a square root, one's a cube root. So those can't be put together. What about 4 radical 5 minus 4 radical 3? Again, not like terms. Different numbers under the radical. What about 2 times the cube root of 6 minus 3 cube root of 6? Those are like terms. These are like terms because they're both cube roots and because they both have a 6 underneath the radical. So what happens when I take 2 cube root of 6 minus 3 cube root of 6? I get negative 1 cube root of 6, which is the same as just negative cube root of 6. Remember that 3 has to be there, otherwise you changed it. Has to be the cube root, so it has to have that 3 right there. Okay, let's try some more. Get 2 times the square root of 12 minus 3 times the square root of 20 plus the square root of 80. Are there any like terms right now? No, no like terms right now, but can I simplify each of the radicals and then maybe have some like terms? Definitely. So let's simplify this. Square root of 12 becomes the square root of 4 times the square root of 3. So this becomes 4 square root of 3, because it's 2 times 2. 20 becomes the square root of 4 times the square root of 5. So that's 12 square root of 5. And 80 becomes the square root of 16 times the square root of 5. So now where's the like terms? This one and this one. So the 4 radical 3 just hangs out. And then I've got negative 12 radical 5 plus 4 radical 5. So that becomes negative 8 square root of 5. And remember that radical doesn't change. If it's the square root of 5 and the square root of 5, it stays the square root of 5. So there's my final answer. Okay, let's try this one. First, do I have any like terms? Nope, but I can simplify these. So 2 times the square root of 150. So what am I going to break 150 into? Something that I do know the square root of. 25. So the square root of 25 times 6 minus 3 times what goes into 54 that I know the square root of? This time I'm not going to choose 27 because remember 27 is the cube root. I know the cube root of 27 but not the square root. So I have to stick with just 9 for this one. Okay, so now I've got 2 times 5 times the square root of 6, so that's 10 square root of 6 minus 9 square root of 6 plus 8 square root of 2. Remember this becomes negative 3 times 3 square root of 6. Okay, so now my like terms are here. So 10 square root of 6 minus 9 square root of 6 is just 1 square root of 6. Plus 8 radical 2. Those are different. So I can write it like that, or Hawks will like you to write it like this. Because the 1 out in front isn't necessary. You don't have to write it in there. It's understood. Everyone knows what you're talking about. So there's my final answer. Okay, what about a cube root one? Let's try this one. So 7 times the cube root of 128. Do I know the cube root of 128? Is that one that I know? Nope. But I know the cube root of 64, and 128 is just 64 times 2. This time I can use the cube root of 27 times the cube root of 2. And then this last radical becomes the cube root of 8 times the cube root of 2. So 7 times, what's the cube root of 64? 4. Good. Times the cube root of 2. Minus the cube root of 27 is 3. Good. You should be answering these really fast. You've got to know these. Cube root of 2. Minus 2 times the cube root of 8 is 2. That's a lot of 2's for that last one. So now I have 28 cube root of 2 minus 3 cube root of 2 minus 4 cube root of 2. So 28 minus 3 is 25 minus 4 is 21 cube root of 2. This time they were all like terms because they were all the cube root of 2. Final answer. One term. Monomial there. Okay. Here I've got to multiply, so I need to multiply this times this. So outside times the outside is 2. Inside times the inside is x squared. And then I multiplied 2 radical x times negative 2 radical 5. So it becomes negative 4 square root of 5x. Then 3 radical 5 times radical x comes 3 radical 5x. And then 3 radical 5 minus 2 radical 5 comes negative 6 square root of 25. So when I multiply, that's when the number under the radical is changing. If I'm adding or subtracting, it doesn't change. Alright, 2 times the square root of x squared. I know the square root of x squared, that's just x. So this is 2x. I have some like terms right here, because it's both the square root of 5x, so I've got like terms. So that becomes negative 1 square root of 5x. And then 6 times the square root of 25. Square root of 25 is 5, so that's just minus 30. I don't have any other like terms. Here the x is out. Excuse me, is outside the radical. So that's not a like term with this one. So here's my final answer, and I'm done.